Hey everybody, this is Larry. This is me going with Q3 of the weekly contest 251, maximum compatibility score sum. So for this problem, the first thing to look, so hit the like button, hit the subscribe button, join my Discord, especially if you like solving this contest problem. Come to my Discord. We talk about contest problems right after the contest. So if that's what you're into, come hang out. Anyway, so for this problem, it's a known problem or a similar variation of a known problem. So yeah, there are a couple of ways to do it. Maybe it's maximum bipartite matching. It's kind of one thing that you can Google up. And others like maybe Hungarian algorithm, things that are kind of very high energy, high powered, will take you a long time to implement. Though I'm sure the top people already implemented it and can copy and paste. But in general, so the first thing, but knowing all that and knowing that those don't really come up on interviews and really rare even in competitive because they're just like trivia to some degree. The first thing that I did was I looked at the constraint, and when I saw that m and n is equal to 8, um, or that there are 8 students and mentors, then I knew that I can do brute force. I actually end up making it dynamic programming, but brute force is good enough because if you brute force, it's going to be, let's ignoring the cache for a second. If you brute force, this is going to be 8 factorial, and each of those 8 factorial permutations, we do a linear time thing, right? So let's just say, I don't know, this is roughly right, I think. But 8 factorial times 8 is going to be roughly 30, 25,000, right? So that's going to be fast enough. The way that I did it was with dynamic programming. So this is actually 8 times 2 to the 8, which is, if you know your math, that's just 2 to the 11. Well, this is exactly 2 to the 11, right? Because 8 is 2 times 2, which is, of course, roughly 2,000. So that's going to be 2048 if you want to note it up. But yeah, so that's basically our complexity. And what I did is I used the bit mask dynamic programming. I have some daily problem type videos that are very good with dynamic programming or bit mask dynamic programming. I'll put a link below and let me know what you think about those. But in general, I pre-cache the score here, which is, and the score is just what they tell you, which is, you compare the answers to kind of get it. This is, I don't know if this is necessary. It probably isn't, but it allows us to kind of do this thing in a more straightforward way because you don't want to keep on doing this every time because that's just more like if you have to look up index and j every time, you know that you're doing redundant work, right? So that's basically the idea behind caching it or just pre-calculating it. And here it's basically, okay, so we have students at index, mentors at used, and the way that I talk about bitmask is that use, you can think about it as in a list of Boolean values, because you can think about binary values as a bitmask as kind of, if we have a list of Boolean values, you can imagine it be like true, true, false, true, true. And then if you convert those to numbers, it would be 1, 1, 0, 1, 1. And, and of course, that's just a binary number, right? Because now you can put them into a binary number, which, and so that's basically the idea behind bitmask dynamic programming. I have it more in depth in another video, so I'll put a link below, or a friendly user might. But in that case, yeah, so students are an index, so we look at the students one at a time, and for each student, we want to map a mentor to that student, and it's pretty much straightforward in the sense that, so we use up this student, and for this mentor, we use the jth mentor, right? And we check that it is unused first, and these if statements look complicated, but if you want to think about it as a Boolean array, then it will just be if used of j if not use subject. If this is a Boolean array, and this is just to set, this is essentially the same as doing this, and then calling it recursively, but bitwise version of what I'm doing here. Yeah, and of course, matching student I and mentor J is going to give us a score of IJ, which I have here, and that's good enough to get us the answer. Maybe I'm going a little bit fast on this one, but I think Leetcode has just been doing a lot of these big mass dynamic programming lately, so I have a bunch of videos on them, so definitely look them up. Let me know what you think. Especially there were a couple of monthly, was it the daily July problems or whatever? Maybe it was last month, but yeah. If not, come to my Discord and ask for a link, and I'll share it there. Yeah. So as I talked about earlier, this is the complexity. It's going to be because we do a dynamic programming cache, it is going to be n times 2 to the n, because actually I think technically it's actually n squared times 2 to the n, and the reason is because, well, that's not true. This should be n times 2 to the n, because index can go from 0 to n, used can go from 2 to the n, but there are a lot of unreachable states, because, for example, index at 2, use cannot be 0, right? Because we literally match them off one at a time. So there's some impossible states, and I think it sums up to n times 2 to yeah, I think it sums to 2 to the n states. Oops. Actually, it sums to the number of states, total number is 2 to the n, and the way that you can see that is that, technically speaking, the index actually adds no information. It makes it a lot easier to program, but it actually adds no information. And why do I say that? Because if you remove index from this, it still works. What you can do now is just index is equal to 0, and then now we can count used, right? So like something like for j in range of m, if used of equals to greater than 0, index plus 1, right? So this is actually the equivalent code, and as you can see, then that means that the total number of states is 2 to the n. This is actually a cool idea. I think it has come up a few times, and which is why I am able to kind of talk about it. But because I keep forgetting to bring it up, even though I knew that this is a thing. So hopefully this is something that will be cool for you to learn. But yeah, so that's just the total number of states. And when I say states is equal to possible inputs. And now that we're, and each of these does O of m work. I keep on mixing m and n. Well, I think n is equal to m in this case. I just misread it in the beginning. But yeah, so each of them does O of m work. Each input does O of m work. Let's just go back to n. So total complexity is O of n times 2 to the n. That's pretty much it. And you can kind of see that the space is the number of input, which is O of 2 to the n. And this is true even if we just had index. So yeah, even though it doesn't look that way. So sometimes it could be deceptive, and you can look into it a little bit more. Anyway, yeah, that's all. I mean, I think you can also add this to n squared times q, I think, but so actually if you want to be more precise, this is this times n squared times q, and space is this plus n squared, because we put it in the score just to make things easier. So but given that n is equal to 8, not really worried about it. Cool, that's all I have for this problem, I think. So let me know what you think, and you can watch me solve it live during the contest. next. Let's get to the next one, even though I'm in a lot of yikes penalty. Okay, maximum compatibility score sum. What is n? Okay, n is 8, so this is just going to be bitmask dynamic programming, right? If n is greater than 8, this is actually the Hungarian algorithm or something like that, depending on some constraints which I'm not looking at right now. But may even be actually just be brute force because it's 8 factorial, right? 8 factorial is 40,000. 40,000 times 8, just in case it's n times n factorial. So yeah, okay, let's do it. You can actually cache this, but I'm still going to write it with bitmask because I'm just more familiar with it. I might as well cache it in that case. And they're always equal. Okay, yep. Okay, and now they have to score. And now to calculate the score. This is equal to. So they just literally go through the array. Yikes. Did I mess this up? Why did I get a 4? Student 0 to 2 for 3. I agree with that. 0 to 2. Did I mess this up? J, no, that's right. Okay, so that looks good. Now that I stop being dumb. Let's give it a submit. Okay, good. Yeah, thanks everybody. Thanks for watching. Hit the like button, hit the subscribe button, join me on Discord. Hope y'all have a great weekend. Yeah, see you later. Stay good, stay cool. Bye bye.